Good morning, physicists. Uh, for those of you who are in class today, this is your opportunity to work on your fourth and final screencast, the physics behind an amusement park ride. There are lots of resources available for you. All week we've been looking at the physics of different rides, from the physics of circular motion rides, to roller coasters and energy conservation, to free fall rides, as well as momentum of bumper cars. Now, all the resources that are available to you are here on E.L. Haynes Physics. And you go to Screencast and to Roller Coaster. And all here are a variety of documents available to you. The grasp explaining the project, the rubric, as well as the checklist that I'll review in a second, as well as a whiteboard template. But then all of the labs that we've been doing all week, not only the lab itself, but also the answer key to go along. So if you had trouble with the calculations, you can check out the answer key. Today you should be working on your whiteboard checklist, which looks like this. You're going to choose your amusement park ride. It needs to be about circular motion, energy conservation, or free fall. Then you're going to look up the necessary information about your ride. The internet is a great resource for this, and so please search the net for your ride that you have decided upon. You also want to find a good video clip of your ride, which will allow you to collect the necessary data for the ride. So it's got to be a nice clear shot of the ride, and you're able to do whatever values you need to figure out for your specific ride. Once you've decided on your ride and you've got a nice video clip of it, then you can really work on the template where you draw a labeled diagram of the ride and include any necessary measurements in your diagram. You take all the necessary data for your ride in a nice data table, and then you figure out answer the appropriate questions for your ride. If you choose a circular motion ride, you're going to need to figure out the radius of the ride, the period of the ride, as well as the mass of a passenger, and then you're going to need to answer these 4 questions that go along with it: the ride circumference, its tangential speed, centripetal acceleration, and centripetal force. If you choose a roller coaster, then you need to find out the height of the first hill from the ground, the height of the bottom of the first drop from the ground, the length of one car in the train, the number of cars in a train, the mass of one car, as well as, using the video, time the entire train to pass the top of the first hill, as well as the time for the entire train to pass the bottom of the first drop. Using all of this information, you should be able to answer the questions of the train's velocity at the top of the hill, train's velocity at the bottom of the first drop, what the train's gravitational potential energy is at the top of the first hill, its kinetic energy at the top of the first hill, gravitational potential energy at the bottom of the first drop, and the kinetic energy at the bottom of the first drop. If you choose to do a freefall acceleration ride, you may not choose the Tower of Doom. That's the one that we did in class, but you can choose any other freefall ride you want. You are going to need to find online the height of the ride, as well as the length at which it was in freefall, how long it takes the ride to reach the top in time, as well as the time the ride is in free fall. And then you need to answer the 3 questions: what is the ride's velocity as it goes to the top, the free fall acceleration of the ride, as well as the ride's velocity at the end of the free fall. Also, here are the different equations that you might use depending on which amusement park ride you choose. The whiteboard looks like this, where you're going to include the name of the ride, what physics standard is based upon that ride. Here's a spot for your labeled diagram. Draw your data tables of the data that you're going to acquire for the ride, and then you have plenty of space for any kind of calculations and unit conversions that you might need to do for your specific ride. Good luck today. I look forward to seeing your products. Again, the project is due next Friday, and so please make use of this time in class to research your ride, as well as start to collect any data. Thank you, and have a great day.